Today we're going to take a look at extending the idea of a function out to a function with several variables in it. And basically what we're going to start to see now is we're going to start to see z, a new variable, is equal to f of x comma y. This is a function with two input variables. X and y that are part of the domain, and these are independent variables. In other words, whatever x is has no effect on what y is. Whatever y is has no effect on what x is. They can be whatever they want. Then we have this variable z, which is the dependent, if I can spell dependent, dependent output variable. So basically we're going to see the x and y as variables inside the function. We'll get some output of z. So for example, just to kind of set it up a bit, let's say we've got f of x comma y is equal to 3x squared minus 2 times the square root of xy minus 5y. Notice this function uses both x's and y's. So then we could calculate what f of maybe 6 comma 24 would be. Notice 6 is in the first spot, that's the x. 24 is in the second spot, that's the y. So we're going to replace all the x's with 6 and all the y's with 24. So we have 3 times 6 squared minus 2 times the square root of 6 times 24 minus 5y, which is 24. And then we can simplify this expression. So we end up with 3 times 6 squared is 36, minus 2 times the square root of 6 times 24 is 144, minus 5 times 24 is 120. Continuing to simplify then each term, 3 times 36 is 108. Minus 2 times the square root of 144 is 12, minus 120. And finally we have 108 minus 24 minus 120 to get our final solution. 108 minus 24 minus 120 is negative 36. So this is the idea of a function in two variables. Let's do another example just to make sure we can really work it. Let's find f of maybe 3 comma 12. Okay. So again, you notice 3 is in the x location, 12 is in the y location. So we have 3 times x, which is 3, squared, minus 2 times the square root of xy, 3 times 12, minus 5y, which is 12. And then we can start simplifying. 3 times 3 squared is 9, minus 2 square roots of 36, 3 times 12, and 5 times 12 is 60. Continuing to simplify, 3 times 9 is 27, minus 2 times the square root of 36 is 6, minus 60. Continuing to simplify, then we have 27 minus 12 minus 60. And that is going to be negative 45 for our output variable. We can stretch this idea then of a function with several variables applying much the same process to get an f of x, comma, y, comma, z. We can have three variables. Maybe that's equal to xy plus 2yz minus 5xz. And so then when we're asked to find f of negative 2, comma 3, comma negative 1, we know that first number is going to go in for the x, the second number is going to go in for the y, and the third number is going to go in for the z. So xy becomes negative 2 times 3. Plus 2yz becomes 3 times negative 1. Minus 5xz becomes negative 2 times negative 1. And then we can start simplifying. Negative 2 times 3 is negative 6. 2 times 3 times negative 1 is negative 6. And negative 5 times negative 2 times negative 1 is negative 10. And so when we add this together, we get negative 22. We can extend this to some of the ideas that we saw in our previous section with functions that we can also plug variables in. We can do f of a, comma 2a, comma 3a. And again, we've got the first is x, the second is y, and the third is z. So when we start plugging it in, x times y is now a times 2a. Plus 2y times z is 2a times 3a. Minus 5x times z is a times 3a. And then we can simplify what we end up with. The first term is 2a squared, plus the second term is 12a squared, minus the third term is 15a squared. They're all like terms. They all have an a squared, so when we combine them, we get negative a squared for our final solution. So that's really all there is new here, is we're just working with several variables instead of just the one variable. So let's try taking this up a notch, looking at some business calc level problems. Let's do f of x, comma y equals 3x plus 2y. We're going to really play with this one. 3x plus 2y. At first, just to make sure we're comfortable with it, let's just do an easy f of 8, comma negative 7. Okay. Well, the function is 3x, which is 3 times 8, plus 2y, and y is negative 7. 3 times 8 is 24, minus 2 times 7 is 14, and so 20 minus 14 is going to be 10. But that's probably too easy, so let's make it a little more interesting. Let's find, same function, let's find f of x plus h, comma y. So now we've got 3x, but x we're going to replace with the entire x plus h, plus 2y. Y is still y in there, so 2y. We'll simplify a bit by distributing, giving us 3x plus 3h plus 2y. No like terms. That's going to be it. How about we try and find f of x, comma y plus h? We'll put the plus h on the y. Well, again, much the same strategy. 3x, 3 times x. Oh, that's just x. Just 3x. Plus 2y. Y, notice, is getting replaced with the entire y plus h. And again, to simplify, we'll distribute through. So we have 3x plus 2y plus 2h. No like terms. That's our final answer. I do notice that both these answers are really similar to each other, but they're a little different, 2h versus 3h, so it does make a difference where that plus h is. How about we do another one? We saw some like this when we were working with regular one-variable functions. How about this with two-variable functions? We're going to do f of x plus h comma y minus f of x comma y all over h. We're going to simplify this. And I'm going to need some more space to work, and I'm going to also copy down the function again. You don't have to do this because you should have it higher on your paper. I just want to be able to see that f of x is 3x plus 2y. Okay, so first f of x plus h comma y. So we've got 3x, which is now the entire x plus h, plus 2y, which is just y. Then you see we subtract the entire function. Just like before, we subtract, we have to put it in parentheses, the 3x plus 2y, all over h. So let's see how this cleans up. We'll distribute the 3 through. We'll also distribute the negative through. Don't forget that negative goes through both terms. So we have 3x plus 3h plus 2y minus 3x minus 2y, distributing the negative, all over h. Combine like terms. 3x minus 3x is 0. 2y minus 2y is 0. So we're just left with 3h over h, which is nice because the h's divide out. And the answer is just 3. What if we did it the other way? What if instead we did f of x comma y plus h minus the f of x comma y all over h? What's this going to be? Well, again, I'll copy the function down just so that I can have it on my screen. F of x is 3x plus 2y. First, we find f of x comma y plus h. So that's going to be 3x, x is still x, plus 2, we're going to do the entire y plus h, minus, notice again we're subtracting the entire function, so that has to go in parentheses, 3x plus 2y all over h. So we'll distribute through parentheses, also the negative, that's the important part we're never going to forget. So we have 3x plus 2y plus 2h minus 3x minus 2y all over h. Combining like terms then, in the numerator, 3x minus 3x is 0. 2y minus 2y is 0. And all we're left with is 2h over h. And that's nice because the h's divide out, leaving us with just 2. These are some great problems to really get your algebra skills up and going. When we get into the real meat of our calculus, we're going to be really, really good at algebra. So let's try another function. Maybe one that's a little more involved. We're going to do f of x comma y is equal to 2x squared minus 3y squared. And we're going to do much the same thing with this guy that we did with the previous. First, we'll do one to get kind of familiar with what's happening. Let's do f of negative 1 comma negative 2. So that's 2x, which is negative 1 squared, minus 3y, which is negative 2 squared. Order of operations says to do the exponents first. So we have 2 times 1 minus 3 times 4. Squaring a negative makes it positive. 2 times 1 is 2, 3 times 4 is 12, and 2 minus 12 is negative 10. Again, I want to stress the order we do things is important. If I was to switch the order of these variables, if I made it negative 2 comma negative 1, we would get a very different answer. Notice then we have 2 times x, which is negative 2 squared, minus 3 times y, which is negative 1 squared. Again, doing the exponents first, we have 2 times 4, minus 3 times 1, and 2 times 4 is 8, 3 times 1 is 3, and 8 minus 3 is a positive 5. So it's going to make a big difference what order we see things in. Okay, so let's get into some fun ones now. Let's do f of x plus h comma y. And again, I'm getting off my screen, so I'm going to just, for the sake of reminding me, f of x is 2x squared minus 3y squared. Okay, so we're going to do all of x plus h in for the x. So we have 2 times x plus h squared minus 3. It's just y squared. Now we have to square the binomial. Remember, we cannot just distribute the squared through. That's x squared plus xh plus xh is 2xh plus h squared minus 3y squared. And now we can distribute through the parentheses 2x squared plus 4xh plus 2h squared minus 3y squared. And we have our solution. No like terms to combine. We're kind of stuck with this guy. So let's take it one step further. Let's do that f of x plus h comma y, and then we're going to subtract f of x comma y, and we'll put the whole thing over h. And let's see what this comes out to. Well, again, I should probably copy the function down. F of x is 2x squared minus 3y squared. That way we have it. So first we're calculating f of x plus h comma y. So that's 2 times x plus h squared minus 3 times y squared. And then we subtract. Notice we subtract the entire function. So the entire function has to go in parentheses. 2x squared minus 3y squared. All over h. Order of operations is going to have us do that exponent first. So we've got 2 times x squared plus xh, and xh is 2xh plus h squared minus 3y squared minus, still in parentheses, 2x squared minus 3y squared. Running out of room. All over h. Distribute through parentheses to get our next part. Remember that negative is going to distribute onto both terms. It's going to change the sign of both terms. This gives us 2x squared plus 4xh plus 2h squared minus 3y squared minus 2x squared, and a negative negative makes it positive 3y squared. All over h. This is looking very ugly. But it gets better. because when we combine like terms, we have 2x squared minus 2x squared is 0. We also have negative 3y squared plus 3y squared is 0. So really all we have left is 4xh plus 2h squared all over h. Of course, before you try and simplify this, you remember that with rational expressions, we have to factor first before we can reduce. Factor an h out of the numerator leaves us with 4x plus 2h all over h. And now because that h is a factor, we can divide it out, giving us our final answer of 4x plus 2h. These are great test type problems. So let's do a couple more. E. Let's switch it. Let's do f of x, comma, x plus h. Oh, sorry, not x plus h, it's y plus h. Then we'll get to the more involved one after we do just this one. And again, just by way of reminder, it's off my screen. It should be on your notes. F of xy is equal to 2x squared minus 3y squared. So, x is just x. We're going to replace y with all of the y plus h. So this is going to give us 2x squared minus 3, and now we have y plus h squared. Squaring, we have 2x squared minus 3 times. Notice we do the exponent first before we multiply by the 3. Y squared, multiply them together gives us yh, and yh is plus 2 yh's plus h squared. Distribute through the parentheses, and we have 2x minus 3y squared minus 6yh minus 3h squared. And there's nothing we can simplify there, so we'll call that our final answer. So now let's try the fun one. The f of x, comma, y plus h minus f of x all over h. And again, by way of reminder, because it's not on our screen anymore, f of x is 2x squared minus 3y squared. So now we've got f of x, comma, y plus h. 2x squared minus 3 times y plus h squared. Minus, again, we're subtracting the entire function, so put the entire function in parentheses. 2x squared minus 3y squared. All over h. Order of operations says we're going to do the exponent first, so we've got 2x squared minus 3 times y squared. We've got a yh and a yh, so that's plus 2 yh's plus h squared minus 2x squared minus 3y squared all over h. Now we can multiply, distributing through parentheses, also distributing the negative through onto both terms. This is going to give us 2x squared minus 3y squared minus 6yh minus 3h squared minus 2x squared plus, negative times a negative, 3y squared all over h. Now that it's all multiplied out, now we can start to simplify. 2x squared minus 2x squared is 0. Negative 3y squared plus 3y squared is 0. All we have left is negative 6yh minus 3h squared all over h. And we know before reducing, we have to first factor out the h, giving us negative 6y minus 3h all over h. Those h's divide out, and we get our final answer of negative 6y minus 3h. So the algebra gets a little bit more involved with several variables, but the process, the ideas, the patterns are still exactly the same as working with regular functions. So on today's homework assignment, you can take a look at these functions, and we will see you in class with questions. Good luck.